Now, the next segment, it will be a showcase of application in data analytics in the financial sector. And for this, please join me inviting on stage the Head of Business Development of AI Products Group of Intel, Mr. Fiaz Mohamed.
The clicker is on. Thank you. Thank you. All right, so thank you all for coming. As the introduction said, I head up business development for Intel's AI Products Group, and a lot of things that I do is focus on industry problems and how AI can sort of help drive innovation there, right? Now, before I go into sort of specific use cases, I did want to spend some time to set some context around what AI is and how it fits into the broader analytics space, right? So let's start with that. Now, if you sort of look at the evolution of analytics and how AI plays into that, right? So if you start sort of with the basic form of analytics, a lot of it is around looking at hindsight, right? So what happened, trying to figure out what happened, and then as a next sort of level of insight, why it happened, right? So why did a specific event occur, with the intention of maybe in the future sort of doing something preemptively to either prevent something from happening or promote something from into happening, right? So there's a lot of traditional operational analytics that sort of falls into the lower left bucket here. Now, as you build more, as you get more data and you get more advanced in your analytics, what you then want to do is start to predict something from happening, right? So what is the probability that a certain event will happen? When will it happen? And things like that, right? And that's where AI really comes in, right? So it's not a replacement, it's more of an evolution of analytics, and it's an enabler more than anything else, right? So that's what AI sort of, how that fits into this broader analytics space, right? Now, AI is a catch-all term that's sort of used and applied very broadly. What it really is a combination of different techniques. So like there's classical machine learning, there's deep learning. I'm sure there's a lot of talk around deep learning today. There's also things like reasoning systems and even sort of a lot of future research that we are doing today within Intel and some of the other companies where we are exploring sort of what the next frontier in AI looks like, right? So it's not a one-size-fits-all. There's a lot of different approaches to how you would apply AI within your own businesses, right? And we'll go a little bit into what those distinctions are. So if you look at, let's say, classical machine learning techniques, these tend to be very sort of statistics-based and rule-based systems, right? So let's say you're building an application to, let's say, detect a person, right, or identify a specific person based on images, right, of people's faces. In a traditional classical machine learning approach, you would specify what features are important to distinguish one face from the other. So this is Tom, this is Mary, and you would sort of say things like the distance between the eyes is something that would distinguish one person from the other, the length of the nose, the width of the mouth. So these are features that you have to specify in an algorithmic fashion to make sure that the system understands what to look for, right? Now, in a deep learning system, though, what you do is you provide, if you're following something called supervised learning, you provide labeled images of each person, and the system automatically figures out what features are important, right? So it automatically looks at these images and says, oh, it seems like the distance between the eyes is something that differs from one person to the other, or the length of the nose is different, and it sort of learns what features are important. Now, in really complex problems, you can sort of imagine how much easier it is to sort of use a deep learning approach as opposed to a classical machine learning approach, because it's just, you're able to train the system based on labeled or sometimes unlabeled data, right? You also have reasoning systems that tend to be, again, there's multiple classes. There's logic-based reasoning, which tends to be very rule-based, right? So you have a bunch of rules, and you tell it, okay, if these things happen, then there's a probability of something else happening, right? You also have memory-based approaches where you're essentially building this sort of association between cause and effect, right? So if you have a lot of different data types, you want to make decisions in real time, memory-based approaches work. So, I mean, the real point here is that it's not, AI is not one approach or one technique. typically when I work with industries, including financial services, what they're really trying to do is use these techniques in combination, right? So they have certain parts of the pipeline that are traditional classical machine learning. Some of them is deep learning, some of them is rule-based. So it's very, it's a sort of a amalgamation of different approaches that are used to solve the problem, right? And so that's something that you need to be aware of. It's not just, AI is not going to come in and sort of replace all your systems, but it, in a lot of cases, is augmenting what you already have in place in terms of analytics, right, to solve specific problems. Now, what we are doing at Intel, you may wonder why, what's a guy from a chip company doing up here talking about, deep learning and AI? Essentially, we are building a full stack solution that addresses AI at scale, right? We are building accelerators at the bottommost layer to make deep learning training and inference as fast as possible. We are building, frameworks and framework optimizations for different hardware targets. And we're also building a suite of software products that make it easy for you as a business and an organization to not only develop deep learning-based applications or AI-based applications, but also deploy them at scale, right? So doing a proof of concept is one thing, but if you take sort of a real-time problem and deploy that across your bank or your financial institution, that's a whole different set of challenges, right? So we are building both the hardware and software to sort of make that as easy as possible, right? Now, one thing I want to sort of step back and talk about is also, how do we look at the different problem domains within deep learning, right? So, what we've found a lot over and over again is typically we look at these problems as what is the domain, right? Not the industry. Like, what is the domain that the problem fits in? Is it, image classification? Is it time series? Is it, tabular data? Are you looking at video? Are you looking at speech? Is it natural language processing? So what happens is some of the solutions that we build in, let's say, natural language processing for healthcare, you can easily take that deep learning neural network and apply that to something in financial services with very little domain expertise, right? I mean, we typically work with clients to sort of understand what the problem is, but in a lot of cases, the neural network that is built for one industry to solve, let's say, speech, right, or to do speech transcription can be easily applied to financial services as long as it sort of fits in the same problem domain, right? So this is how we look at the world. It's not about industry verticals, but it's the types of problems. What are the types of problems you're looking at? Because there's a lot of transfer learning that will happen across industries as long as the problem domain is same, right? And I'll start going into a couple of these examples, but this is one of the sort of early proof of concepts that we built for a very large financial services company based in North America, right? So, imagine this: a lot of these large investment banks have thousands of analysts that are trying to understand what the market is doing in real time, right? So what is happening in the news today? How do I keep up to speed on all the events that affect a specific stock or equity or bond or whatnot, right? So it's a huge challenge for a lot of these banks. So it's essentially, they came to us and said, well, how do I make this as easy as possible, right? So there's all these documents that our analysts read day in and day out. Essentially, it's thousands of documents a year. So can we use deep learning techniques to sort of make this and accelerate this sort of knowledge acquisition easy, right? So we used something called unsupervised learning, right? So you may have heard of this in the past, but essentially what we did was we took both public and internal documents, right? So Bloomberg reports, SEC filings, and all sorts of sort of publicly available financial documents, right? And we also took some of the bank's internal documents and said, well, can we use deep learning to sort of understand this sort of huge corpus of data, right? And what you're looking at on the right is essentially a multi-dimensional map of all the words and phrases that occur in these financial documents, right? So it uses deep learning to understand sort of what words mean, how they relate to each other. So let's say I come in and ask a question like, what is the competitive landscape of the pharmaceutical industry in China, right? It's a very, very complex question to answer because, well, what does competition mean, right? It's easy for us to understand what that means, but to train an algorithm to do that is a fairly complex task. So it looks at the word competition and says, well, what are the related words to that based on sort of how often it occurs in proximity to the word to other words, right? And so what it does is it starts to build this multidimensional map. So each dot here is a word or a phrase, right? So now when an analyst goes in and asks a question around, well, tell me about the competitive landscape of the pharmaceutical industry, it's able to sort of surface all the paragraphs, sentences, words, documents that are relevant to answering that question, right? Now, if you were to do this in a sort of traditional machine learning approach, what you essentially have to do is almost hand code this for every specific industry and every specific domain that you're trying to build a knowledge management system for. What we did here, though, is we just pumped a bunch of documents into this deep learning neural network. And it was able to sort of learn these associations automatically. So this is really, really powerful. Now, you can use this for all sorts of different applications, but in this case, it was about accelerating learning within the bank, right? And the other thing, the other advantage to this approach is also you can continue to make this sort of more accurate, right? So the more documents you feed it, right, it gets smarter, right? You can also have a human sort of intervene and say, hey, by the way, this document doesn't seem relevant, right? So maybe the machine is trying to sort of having trouble learning, and you can go in and have a human sort of mark some documents as being irrelevant, and it sort of feeds that into the AI system. So the next time it keeps that in mind, right? So it's a continuously learning system that you can sort of make stronger by either adding new documents or by even having a human sort of intervene in that learning process, right? Here's another one. So this is something that we did for another financial services company that has a trading system, right? So traditionally, again, you're all aware of this, right? So you have a really complicated trading system where you have sort of bids and asks, and there's a lot of historic data on what price each equity was sold, at what volume, and things like that. So what they were trying to do is say, well, let's say this system receives an order, right? So, I don't know, 100 shares of equity X, right, at a specific price, right? Now, what is the probability that this order is going to be fulfilled, and at what price is it going to be fulfilled, right? So they want to build this sort of slightly more intelligent trading system where it's able to predict whether this order will be fulfilled or not and at what price. Right? So again, what we did here is a very similar approach to the previous one. So we actually took a bunch of sort of historical trade data, right? So everything from who placed the order, what was the order size, what was the asking price, who actually fulfilled the order, and sort of using this historical data, we are able to sort of train this neural network or AI system to more accurately predict if this order is going to be fulfilled or not. Right? Again, this is something that I think we did a few months ago, and the bank in question is actually thinking about sort of deploying this. It's an initial first step to making this order system much more intelligent, right? So this is, in a lot of cases, you're starting to build solutions to much bigger problems, but you're using a sort of a small data set to sort of train the system and eventually make it much more intelligent, right? And finally, this is another interesting one, and this is the last example. So this is actually a stock exchange that we work with in the US. And very interesting use case where, obviously now again, if you think about what a stock market or stock exchange does, is they have these constant trading, right? So they have market patterns that they want to track, but not only track, but also, going back to that initial analytics slide, they want to start to predict the possibility that something is going to happen, right? I mean, we'd all love that, right? But again, this is not a solved problem, but they're starting to build AI systems and deep learning systems to take specific patterns in the stock market and say, well, given this pattern, right, what's the probability that something else will happen, right? And how do you do that? I mean, in a lot of cases, you have to rely on historical data, right? It's just one data point. Obviously, not the exact same thing will happen over and over again, but it's one data point you can use is saying, okay, well, given a specific pattern, can I find similar patterns in history that match this, what's happening today, right? Or what happened yesterday, right? And the idea here is to say, okay, well, this specific trading pattern happened, XYZ day, 5 years ago, right? And it happened again 2 years ago or 6 months ago. And what you can then do is start to build these more intelligent correlations between patterns that are occurring in the stock market. So what we built here is, again, a pattern matching deep learning neural network. So saying, okay, well, we take this slice of history or slice of trading, and we're going to build a deep learning model that can find similar patterns in history so that we can start to build these more intelligent predictive models. So again, we used a neural network to sort of ingest order book data. So order book data is very similar to what I was talking about earlier. It's essentially a list of trades, right, and patterns in stock fluctuation and orders and things like that. And then we trained the system to sort of understand these patterns and then automatically sort of look for historical occurrences of similar patterns. So this will give you a sense for the types of problems we are solving. Now, going back to that earlier slide, though, many of this is, the last two examples are time series data. The document analysis we talked about is more around sort of natural language understanding and processing. There's a lot of tabular data that may occur. There's speech, right? So we worked with companies like, again, large banks that want to capture every audio conversation within the bank for audit purposes and compliance purposes so they can understand the conversations, right? And so they can go back and understand intent of something happening and sort of analyze speech to make those sort of correlations. Video is something that you could apply in a retail bank situation, right? So again, face recognition, right? Somebody walks into your bank and you are immediately able to identify the person based on their facial features. Image classification, again, is very similar. But video is, it's very common in surveillance. You want to make sure that you're tracking specific type of activities and raising alarms. But the image one goes back to the facial recognition example where you can look at a specific video feed or image feed and sort of identify this person or object, right? So that's pretty much all I had. Thank you again for joining us today, and I'll pass it on to the next speaker. Thank you.
Thank you very much, sir. That's right. For this segment, we have 3 speakers. And next up, for the second speaker, ladies and gentlemen, please join me in inviting on stage the head of marketing analytics of PayPal, Mr. Abhi Gupta.
Thank you. Hi, everyone. Hope you guys are having a great day, especially given the first day of the conference. What I wanted to talk about today was the dichotomy between data and insight. And I wanted to kind of, story play a little bit, give you a couple of examples of what I have done at PayPal with the right data, but also asking the right questions and getting to the right insight. So with that, I kind of wanted to give you a little sense for PayPal in general. Hopefully, many of you are aware of PayPal, but let's talk about the scale of what we are talking about. This is just information from our last quarterly results. And in just the last quarter, we processed over $100 billion in total payment volume, which generates, again, a lot of data, a lot of transactions. We know a lot about customers, what they shop, where they buy, what they buy, and when they buy. We also have a significant increase in our mobile payment volume. So of course, the world is moving mobile, but so are payments. and it's almost over 50%. So that's where our growth is coming from, which is amazing. But that also keeps adding to challenges in actually utilizing data, given that there is a little bit of more control with what you can get with mobile data, less data a little bit compared to the web. We also have a lot of active consumers. Now that may pale in comparison to some other organizations that are in the payment space as well, but given that we have not even entered China or India aggressively, that's still a sizable amount of customer base. In fact, we just entered India domestically, so this number hopefully should go up significantly and add to the data that we have. And finally, we actually in the US, I'm not sure if you guys are aware, we have a peer-to-peer payment company called Venmo. And what they do is social payments. Essentially, when you send payments to each other, you're supposed to actually enter why you're sending the payments. And in fact, it is mandatory for you to enter why, which one would think would actually negate the ability for customers to process or transact. But in fact, we have found that it actually leads to much more higher engagement with those customers. So significant is the growth in Venmo that it has been growing almost 100% every quarter, which is huge in that market. And we haven't even monetized it yet. We've just started to monetize it, which means, again, it will generate a lot of useful data. However, data or big data alone is not useful. Data does not equal insight. What do I mean by that? Well, in marketing analytics, a lot of my partners come to me and say, well, how do you help me run this campaign? You have tons of data about the customer, so why can't you actually tell me exactly, precisely who to send this message to? Well, that's really called insight, right? And that involves manipulating the data, extracting information from the data, then packaging it into something that is actionable. And that is challenging, because that involves human interpretation, actually, and human action. What I've found, working in this area is that asking the right question is the most important thing. Not just analyzing the data, not just building a beautiful model that somebody can take and run with it, but actually working with business partners to understand what is the concern that you're trying to solve, and why do they need this information. So with that, I wanted to kind of give 2 examples with how asking the right question can actually change the trajectory of the action. In fact, big, huge changes in how the company thinks, just by very simple changes in interpretation of what you're looking to do. So the first example that I will talk about is segmentation. And most of you might be aware that there are multiple ways to segment customer bases, but I'm going to pick one of the simplest ones and one of the most useful ones that is age-old but still works today, called the RFM. As we know, it is recency, frequency, and monetary. At PayPal, we've modified it a little bit, but I'm going to still take the classic example and talk about it. Now, the history of PayPal is that a lot of the business units and a lot of the business folks were incentivized based on revenue, right? Generating revenue. And how does PayPal generate revenue? Well, when you spend $100 online, let's say to buy something off of a merchant, we take some cut of that from the merchant itself, roughly about 3%. So we make $3 off of every $100. That's the revenue, right? But ultimately, is that the right measure? Is that what the company is looking for? And does that define the value of a customer? Well, given that the businesses were used to looking at revenue, that is how we built RFM. So M in the RFM is called monetary, right? And that's kind of what we used is just the revenue piece. With that, we actually built the segmentation. We divided customers into various segments, scored them, and then figured out what the Pareto might look like for that segmentation. And this is what it looked like. What it means is basically, in terms of a Pareto, is what the number we are looking for is 3.3, right here. That's the segmentation based on revenue. Now, most of you are probably aware of the 80-20 rule. The 80-20 rule says that 20% of your customers make up 80% of the value, in which case the traditional Pareto, or the perfect, if you will, Pareto, or theoretically, is 4, right? Now again, this is 3.3, decent, good enough. However, one of the tasks that I was given this past year was, well, let's take a relook at that segmentation and actually ask the right questions about who are our most valuable customers. And I challenged the business leaders and said, well, margin is what matters most. Why? Because our business is changing drastically. I'll give you an example why. That came to my mind, and I had to fight against it. And because still, they're incentivized on revenue. I couldn't change that, but I could change how we look at the customers. So what has been happening with PayPal is we used to actually enforce using your balance if you have any money in our account. Why? Because it costs us zero to spend it. So we have no cost. So everything that you use or we get from the merchant, we pocket all of it, right? If we use balance in your account. That's highly profitable for us. So we don't want you to, or we didn't want you to not use balance. Therefore, we would default everyone who had any money in their account to actually use the balance every time you transacted. However, that actually eliminates customer choice. And that, over time, we found is negative in perception and usage and loyalty with the company. So we actually took a big bet recently, last year. We said, OK, we are going to allow you to set preference across in-store, online, mobile, any kind of checkout. And you can get to choose which particular credit card or debit card or bank account or balance you want to use in which use case. Now, that is a big deal for us because it is going to eat into our margins. Right? We baked that into our financials and all the projections that we made to the Wall Street. But in fact, then this dynamic changes what customer value means to us. It is no longer revenue because we don't have a set system of extracting the most value at the underlying level. We are giving customers the choice with the hope that they will actually engage more with us. That was a rationale for me to actually convince our leaders to look at margin instead of revenue. And we did the same thing. We actually ran our FM. I won't get into the statistics of it. We actually changed quite a bit in there, advanced statistics there. But the result of it was this. You can see that we compressed the top customer base while increasing the amount of value that they generated, in terms of identifying them. In fact, our Pareto was better than the theoretical Pareto of 4. It's 4.3 now. And that has been a significant shift because not only did it increase this, it actually changed fundamentally a lot of the customers that we thought were top customers were no longer top customers for us. Therefore, our entire strategy of how we interact with them, how we actually talk to them, how do we learn from them changed. Just by asking one question. What does it mean to be valuable to PayPal? And that actually means roughly 30% improvement in the Pareto. Quite significant. Now let me go to another example, which is around targeting. Marketing analytics is a lot about campaign management and helping marketing think through who to target for what offer or value proposition message or any kind of marketing message, right? Or introduction of new products. One of the use cases is that we send a lot of offers and we want to make them relevant. And a classic way to make offers relevant is to use what is called a propensity model. At the basic heart of it, a propensity model is predicting the probability of a customer to undertake an action, whether organically or enforced. Now, we actually built propensity models for this particular campaign. And what we found was when we ran an A/B test, we actually observed no lift. And given the cost of offers, we saw negative ROI. And that was very concerning because, one, we couldn't explain why this would be the result if we were very confident that our ability to build models is great and comparable to anyone in the industry. Secondly, and more importantly, it actually made our credibility go down with the marketers because they were like, well, you're trying to sell me a black box model and it doesn't work. And you're trying to explain to me all these statistics, but you can't give me a rationale as to why it didn't work. And the reason for that at least in my mind, was, are we asking the right question? Because the question that the marketing team asked generally to us was, build a model for customers who like gaming merchants so that I can give them gaming offers. That's the wrong question. The right question is, tell me which customers would buy this product only because I send them a marketing message and would not have bought it otherwise. That is the one target segment. If we could answer that, that's the golden answer for marketing. So looked around and challenged my team to come up with an answer of how do we identify those customers who will fit this question. And we actually found a technique called uplift modeling. And at the basis of it, what it does is it actually does, you do a random test and you look at the results in A/B. And what you see is you kind of split customers in a 2x2 matrix. I used to work for BCG, and that's one of my favorite things, is to split customers between a simple 2x2 matrix, easy to explain to marketers or any business folks, and it makes sense. So at the underlying logical level, what it is you have a certain type of customers who would buy if they do not receive an offer, whether they buy or not. And you have another on the other dimension, people who would do that action if they did receive an offer. And what you see is that a propensity model actually talks about or identifies customers who are basically all quadrants except the lost causes, which would not buy anywhere, right? So what it's doing is really indexing on customers who would buy it with the offer, without the offer, all that stuff, right? So for that particular campaign, what we actually thought was that this particular propensity model is actually biasing towards customers who would have done this action anyway. And therefore, we are wasting money trying to get them to do something. It's almost like, if you were going to go and buy a Reebok shoe and you were planning to do it, and I sent you an offer, oh, here's $50 off. You'd be like, woohoo. I mean, that makes sense. Like, I was planning to buy it anyway. I'll use the offer. I'm not going to generate incremental sales to you because I was going to do that anyway at full price. Therefore, I'm actually, going to use it. And in fact, for PayPal, that'd be bad news because we'll lose money. So, this is a good statistical technique. It's relatively new. For example, propensity models have been around for 20 plus years. This is less than 10 years old. And it is not very, it's not very based, in terms of a lot of experience. So it is a test and learn kind of technique. And you could get it wrong. But we got it right. We built this model, and we actually saw for the same campaign, no change to creatives, just the targeting. We actually then, in fact, saw 100 to 200 bips lift in transaction activity for those customers, and a roughly 200% ROI. Again, by asking the right question. Of course, we had to go through a painful process of getting it wrong first, and then investing a lot of time to get it right. But this is an example, classic example of when you actually ask the right question, when you dig deep under the motivations of what the business is trying to do, you can arrive at the right answer by looking at data in a different way. So, in summary, the quantity of data is exploding for any organization. Let it be PayPal, or let it be FinTech, or retail, or any other industry. Big data alone is not useful. It cannot devise insight until you ask the right question. That's it. Thank you.
Thank you very much, sir.
Thanks.
And before we invite our third speaker for this session, now, ladies and gentlemen, we do have more seats in the front. So if you like, our guests at the back, please feel free to take up the seats in front. And now for the third speaker for this session, ladies and gentlemen, please give a big round of applause to the Chief Technology Officer of SAS Asia Pacific, Mr. Deepak Ramanathan.
Thank you. Good evening. So the good news is this is going to be the last session, right? So you guys will get a break out of it. Also, compliments to the conference organizers. I felt I was in Las Vegas at the CES, right, the Customer Exposition Show. I've never seen so many bankers under one roof, unless it's the golf course on the national holiday. So, I mean, it is really exciting times for us. I mean, it's really exciting to see this crowd. It's really exciting to see the interest in analytics. And I'm going to be talking about how at SAS we are viewing this next generation of analytics and how we are talking to and addressing some of the challenges that customers are facing in this next round of analytical growth that they're seeing. So all the speakers before me spoke about analytics in one shape or form. If it's a query or if it's a Pareto chart. The thing is, we are now headlong into the analytics economy. Right? We're right in the center of it. And analytics is right now leading into leading into disruption. So disruption is also leading to innovation. So a lot of organizations are building out product innovations or service innovations on the back of analytics. Right? And at SAS, in some ways, we feel we are the youngest startup in the world at a good old ripe old age of 40 for software companies. So in the next 15 minutes, I'm going to talk to you about the hard work that is required in order to make your analytical journey a successful journey. What is actually needed from an analytics outreach and from a view program of how do you take analytics in an organization and how do you really deploy it and make it operational, right? So, as we spoke about the analytics economy, we are seeing these new digital transformations that's taking place, and I'm sure you must be hearing this word over and over again about digital transformation. So what do we see from a digital transformation perspective is analytics is the center of the digital transformation. And the reason for that is analytics runs on data. And what we're happening with the digital transformation is providing more access to data, more structure to data, and also looking at brand new data sources when none of them existed. I remember the Intel speaker speaking before I did about how new techniques are coming up in terms of deep learning, machine learning, etc. So analytics is the key for any of these digital transformations, and where we are seeing the growth or the emphasis of organizations when it comes to analytics around these following areas. One, of course, is automation. Right? How can analytics sort of drive some of the automation within your organization? Right? So analytics is key for a lot of the automation because it essentially allows you to make those decisions in automated fashion. Customer journey optimization. Right? Again, a lot of speakers before me spoke about the value of customer journeys and how you actually map out those different customer journeys, look at lifetime values, and how do you optimize each cycle of those journeys. And it's a lot about customer satisfaction right now. So any kind of product innovation or service innovation is taking place. Customer, especially in a B2C business context, customer tends to be center and front. Combating disruption, right? So the power to disrupt is immense right now, and it doesn't take the cost or the barriers to disrupt have significantly gone down. So disruption is big on the key for organizations, which is driving a lot of their digital transformations. Open business models, right? You see open business models, and MAS in Singapore, of course, is leading the way around and showing how you can drive those open business models. And you'll see a lot of banks in Singapore actually helping that model of open business models in terms of opening out their APIs, collaborating with other organizations, and making sure that intelligence and wisdom goes back and forth within those organizations. And last, but certainly not the least, and you cannot escape a conference without hearing the word AI, artificial intelligence. We go back to maybe 6 years ago when you couldn't go to a conference without hearing the word big data, right? You could hear big data everywhere. What was big data? Velocity, volume, variety, value, right? So AI is now in some ways and form taking up that shape of what they call for big data. But AI is here, and the way organizations interpret AI varies from organization to organization. It's a larger taxonomy of analytical procedures and algorithms that help you achieve an outcome, right? That's the way we would love to define AI. And we believe that SAS is going to help out with a lot of the transformations. So, what is the hard part? right? And if you look at the hard part, I call this the trinity. It's the holy trinity of data, discovery, and deployment, right? And I call it the trinity because, I mean, you heard Abhi speaking before me from PayPal talking about insights, right? So the first and foremost activity in any kind of analytical journey is actually getting data, right? And understanding what the data is. That's a famous saying about for a data scientist or a quantitative analyst, 80% of their time is spent in doing data management, right? And the remaining 20% is spent complaining about the 80% of time they spent on doing data management, right? So there's a lot of data management that's done in this process, and it's the backbone of any kind of insight that you would like to have. The discovery part is the insights, looking at the data, understanding what patterns exist in data, and then finally actually going ahead and building out statistical models to understand how this data actually functions, right? But the hardest part for most organizations has always been deploying these insights into consuming applications downstream. How do you take a statistical model, whether it's a logistic regression, whether it's a neural network, whether it's a facial recognition, whether it's a generalized linear model, how do you take this intelligence, this model that you have built, and how do you deploy it into an operational scenario? That has always been the last mile problem, right? And we'll speak about how we are looking at solving that specific last mile problem. For instance, most organizations today are looking at how do you deploy this analytics into consuming applications. So whether it's a mobile device, it's an embedded device, it's embedded analytics. And the power of analytics comes in when people start using it, and then you start getting feedback around how that uses, because these are all these self-learning models that keep running to understand how customer behavior is changing over a period of time. So unleashing analytics is incredibly important. The deployment is incredibly important. We have the next one, which is essentially there are advances that are taking place in computes, right? And if you look at the kind of compute power that you have in your phones, especially if you have the new iPhone X or the Samsung Note 8, I mean, you're talking about multi-core processors that are capable of doing federated machine learning if required. So you can actually have machine learning running right at the edge on your phone, which is a huge difference that we are looking at. And with the onset of GPUs, graphical processor units, not CPUs, GPUs are now becoming very good at solving certain vector problems. So things like image recognition, et cetera, those problems can be solved very well with GPUs. And GPUs don't have 1 core or 4 core. They start off with thousands of cores, but are fit for purpose. So that's really changing the paradigm in terms of making the models faster and therefore many more, right? So you're not going to deploy the models at the edge, but you're also building many more models because you can, because the speed has increased. The reason you can do deep learning today and number crunch those kind of neural networks is because the compute power is massive and the compute power is parallel. But what's missing going forward is how do you define governance for the entire process, right? How do you have governance when you build out a model and that model gets deployed onto a consuming application downstream? How do you ensure governance that this is the right model running, the model is still efficient, it is still of high efficacy, and should the efficacy of the model go down, how do you replace that? So the governance part is incredibly important, and we are seeing it more and more. Some of the laws that are coming out of Europe and some of the ones in Singapore about privacy of data lends themselves to governance. Governance will be key when you start managing these hundreds and thousands of models you'll start building, because now you can not only build them, but you can also easily deploy them. So the analytics economy, which a lot of you have been touched by, and the reason I've seen a lot of you have been touched by, whether you use a phone or you use an app or you watch any of the programs on TV, you're all touched by analytical applications. It could be an optimization engine that you're seeing when you're calling for a taxi, or it could be a recommender that comes up and says, hey, well, you saw these movies, we recommend these movies to you. So you're already consumers of analytics, right? Each and every one of you have already started becoming that journey around that consumption of analytics. So the question that you have is, how do you make that analytics easy? And we believe at SAS that the API economy will pretty much power the analytics economy. So analytics, consumption of analytics is going to become a lot more easier because we will have the power of APIs to start requesting for these particular algorithms. Let me explain what I mean by that. So we started off as an organization in 1976 out of university, right? So we were a university organization, and in the past 42 years, we have built out hundreds of algorithms, right? Simple problems to solving quality control, to solving optimization problems. What we have done right now with our platform is we have now made all of these algorithms now available via a simple API call. So for banking organizations out here who are using our, for instance, real-time fraud detection, if you're using anti-money laundering, if you're doing Basel II risk compliance, credit scoring models, if you're doing the latest and greatest in IFRS 9, all of those models are now available via API calls, right? So we are now opening out our entire ecosystem, which is, I told you about the open platform requirement that's coming up, opening out that entire platform ecosystem so that you could have consumers or creators at one end that you see on my right hand, which is the producers, who can go ahead and build out these models and make it easy with this whole common microservices kind of architecture to make that, to consume that information further downstream. Right? So building the model and then deploying the model now becomes a lot more easier, but at the same time, you're not sacrificing on the underlying governance and the underlying lineage and also the underlying control of the models in terms of how these models are actually rolled out. So you have all of those pieces in place, but you're now making those models a lot more easier to consume. So at SAS, we believe this is going to really power a lot of collaboration and innovation for customers in being able to then start developing innovations around products or around services, right? Both of those, and a lot more things that are coming along with that. So included also, we are now making this foray into natural language processing. We're also doing a lot of work in image recognition, and more importantly, we're doing a lot of work in things like deep learning, neural networks, LTSM, those kind of new algorithms that are coming to bear within the market. All of these are going to be available on what we call the platform called SAS, on SAS Via, which enables you to optimize all of your applications and then also allows you to start consuming all of these algorithms that SAS has built in that 41 years of history and heritage to start consuming those time and tested algorithms. We are looking for FinTech partners, right? So we are looking for FinTech partners, and we think this is a great venue to sort of seek out and reach out. And if you are interested in any of these applications, please feel free to take a photograph. You can link up with me on Deepak Ramanathan. I'm available on that. And we also have a website called sasfinovate.com where you can sign up as a FinTech, and we'll sort of provide you these models available. There's more details that are there available on that particular site, right? And with that, thank you very much for your time. I hope you have a great conference. Enjoy the remaining 3 days. And again, if you bump into us, please don't feel shy. Let us know what you think. Thanks very much. Bye-bye.